Well, hello everybody, and welcome back to the bench. As you can see, we have our next little project here, and this one's going to be pretty interesting. This is a Pioneer model KP-500, and it's an underdash automotive cassette radio with FM tuner. And the unique thing about these, they're pretty collectible, is this performance, the audio quality of these for what they were. They had a very high quality tuner in them, and actually a pretty good quality tape drive in them, just for a little tape player. But they especially had an excellent preamp and amplifier. As you can see, you have balance, bass, treble, you have a loudness switch, you have muting, you have local distance for the tuner. It is just a really kind of patterned after a home audio stereo. Now, the thing that's always piqued my curiosity was if you look at some of these features, like the performance, they talk about the frequency response being 40 to 10 kilohertz. But you have to remember, and the frequency response for the radio section was 30 to 12 kilohertz. Well, really, what they're telling us is the actual frequency response of FM stereo and the frequency response of standard cassette. In other words, normal bias cassette. But really, I believe that the amplifier in this will probably have a full frequency response from 20 hertz to 20 kilohertz, and this is something that we want to test out. The purpose for this is, obviously there's not really a whole lot of cars anymore other than a classic vehicle that you could install one of these. It is relatively big. You can see how large it is. But it's also, for a home audio, it's very small and compact. So it's something that I'm considering maybe using as a bench stereo. Number one, so I can listen to the radio here, while I'm working at the bench. And second of all, that I could have a good preamp and amplifier. We're going to put some input jacks on this and put some switching on it so that we can actually connect up devices, whether it's an MP3 player, a CD player, cassette player, whatever we're testing on the bench, to have an amplifier to test it with. So that's kind of my plan, that I'm going to repurpose this thing. So if that sounds like something interesting, stay tuned, and this is what we'll be working on for our next project. Alright, so I've gone to the stereo internal microphone on the camera, so I'm not sure how it's going to pick up my voice or this radio, but we're going to try it. And let's see what this thing sounds like. I have a antenna connected to the outside antenna. I have a set of speakers, and I have a power supply connected. So let's turn this on. Sweet lives, losing again. I was loving all the wrong places, looking for love in too many faces, searching for eyes, looking for traces. All right. Rings starting at $1,999. Courthouse Square. Let's prop this up. Well, I guess it works. So that's a good sign. Sounds like the FM could probably use a little bit of alignment, among other things, but it works. Let me see. I don't know if I have a cassette handy, but and anyhow, it probably needs a new belt anyways. But let's get this thing apart and see what's inside. Okay, we're in. And as you can see, on the top side anyhow, you just have the one board up here, and this is where your tone control and everything is. Then this is a slug tuned receiver, meaning it uses these ferrite slugs and then some tuning capacitors. As you can see, when you a lot of car radios are like this. So if you notice, you can see how it's driving these slugs in and out to tune the radio. So it's a little bit different. It's an inductive tuning rather than capacitive tuning, I guess is the best way to put it. And you'll find that most car radios and so forth use this. The other thing they'll do is they'll use a different intermediate frequency, at least for AM. Now I'm not sure on FM what the IF is on this one, if it's 10.7 megahertz. I really haven't looked, but there is a complete alignment procedure for this tuner, and believe it or not, they follow a lot of the same procedures for this car stereo as they do for their home stereos, which is pretty cool, I think. If we flip it over, here's your tape transport assembly, and it just has the one belt here, and the belt actually looks to be in pretty good condition. It might need a little cleaning, or it might be a little bit loose. Not bad. But we also have a spare belt though if we need one, and you can just see how well built this whole thing is. There is this idler tire, and it seems to be in really good shape. So this is not in bad shape. Down here is your actual tuner. If you look down here, and there's not a whole lot involved. There's a couple of cans here that we can adjust, and a couple of pots, and that's really all there is. And over here there are two of these AN214Q amplifier chips, and these are, I think these put out about 8 or 10 watts each. And if you see, there's one here and there's one back in here, and obviously we'll probably go through and recap this, because if you notice, the sound did sound a little bit distorted and underpowered. I was only drawing about a ½ amp on my power supply. I know I have that power supply can easily deliver 3 or 4 amps with no problems, and even with only a ½ amp of current draw at 12.7, 12.8 volts, this was distorting it without getting too high volume. So probably needs a recap, and we're going to do that, and then we'll do our tuner alignment, and then we're going to make a few changes. One of the things I want to do is get this antenna jack out of here, and I'm going to replace it with the BNC so that I can connect a coax to my external antenna. And then I'm going to probably put a couple of RCA jacks for inputs, and put an AB switch to switch between tuner input and auxiliary input. So that's lots to do on this. All right, I have the back panel off, and you can see this is going to actually be pretty cool, because I'm going to, first of all, we're going to put some heatsink grease on here to kind of make a little more heatsink surface out of this. But also, we're going to try to put a face plate on this, and this looks like a good place to mount some speaker terminals, the input jacks, and the little switch like we want to do. And we now have easy access to the amplifier module, which we're going to have to take apart to be able to recap it. In order to do that, we're going to have to pull the heat sinks off, which just looks like these 4 screws, and we should be good to go. So I'm going to get this apart and we'll get started. Well, here's the finished product, and she's back to life from the 70s. I have to admit, today I got so many emails and messages about this little receiver. I couldn't believe it. Everybody was coming back and saying, hey, I had one of those in the 1970s. I had the 8-track version. I had the newer version, the older version. I found out that there were different revisions of this and everything. Really, the reason I was interested in this was when I was a kid in the 70s, there was a store that sold these, and they had them up front, and they had it in one of those demo panels where you could listen to it. And I was always so impressed, and of course these were so expensive back then, and I always wanted one, you know, to put in my parents' car or whatever, or put in my first car. Of course you couldn't afford it back then. I didn't have any money. But anyways, here it is, and you can see there's been quite a few changes I made to this thing, and it was quite a challenge. I'm going to show you a couple things that might, if you decide to do a conversion of one of these, a couple of pitfalls you may fall into if you don't watch. First thing you'll notice is I took out the old speaker and power connectors, and where the wires came out, I just put a little front connector on there, or a little plate. You can see I wired it behind there, and put some RCA jacks in. We'll get into this here in a minute. Up here I put a power jack, and on the back of it, if you look, I just shunted a 4700 microfarad capacitor just to kind of help with a little bit of the current limit, or you know, the little bit of surge current and so forth. Right here I actually installed a switch, and this is going to allow us to switch between the internal tuner in there and these RCA input jacks, so that we can connect an MP3 player or any other line level input that you want. I also put 4 speaker jacks, so here's your right and left speaker jacks. And then finally I got rid of the car antenna connector and just put a standard BNC so that I can run from my outside 2-meter antenna, just to use it to be able to listen to it in here. Now here's where the interesting part is. If you look on the schematics, you know we can't do a video without doing some schematic stuff, huh? If you look here, here's the tuner, the FM tuner, and these 2 wires are your right and left stereo outputs. These are line level outputs from the tuner, and they go straight down into right between where your tape head preamplifier and your tone control amplifier preamp is. And you can see it goes in here, goes through these little transistors, through the tone section, through another little set of drivers, comes off of this board, and then goes on to that power amp board that we were looking at. And I did replace these 2 output capacitors that go to the speakers. I did recap this board, although I don't think they needed it really bad. It was just kind of a precautionary thing, a couple dollars worth of caps. But here's where it's interesting. At first you might think all you need to do is disconnect these wires and connect your RCA jacks in there, and you can directly drive right into the preamp. If you were to do that, it would not work on this. This is a very interesting circuit. You have to really kind of look at what's going on here. First of all, when they come in here, if you notice, it goes through a couple of 33K resistors, for one for each channel, and then a steering diode. And if you notice over here, coming out of the tape head preamp, you also have a couple of little steering diodes. And so what's that all about? Well, what that's all about is that this is an automatic switching circuit. It kind of, the way it works is whichever one of these devices is selected, it will turn a voltage on, and there's like a DC voltage riding on here that will basically cancel out the other channels and only allow the signal to come through here. So in order to get this to work properly, if you just were to hook your line levels in here, you would get a very distorted, almost no sound at all. It would sound like a blown channel or like a shorted transistor or something. And it could even possibly damage your MP3 player. But here's how we take care of that. If you look down here, let me get you zoomed in. If you notice, I have 2 wires, these 2 with the red heat shrink. These are coming from those RCA jacks. These are the positive leads of the RCA jacks. Ground is ground all around, so we're not worried about that. In order to get this to work, First of all, you have to have a double pole, double throw switch that will switch between the original FM tuner. So these two wires come from the FM tuner, right and left channels. These go back out to the board, to the preamp board, right here, where those two wires used to be. And then this side, it goes through these decoupling capacitors. These are 2.2 microfarad film capacitors. You can see them, 2.2 microfarad. And they're decoupling the DC. Then on here, what I did was, this is the switched 12 volts. So this is your 12 volts DC, and it's switched. It only comes on when you turn the radio on. And it goes through two 47K resistors. In other words, one end of the 47Ks is tied together and goes to 12 volts, and then each one goes to a channel and then goes through this steering diode and out to the preamp. So what happens is, when we switch this over, this voltage will activate those transistors here and switch them on. These will block, so it'll just think it's the FM tuner, and everything will work fine. If I disconnect that 12 volts, the sound will cut out. You won't get any sound. So that's it. It's that simple. So you have to build that little network. If any of you are more interested, if you're going to do this, if you have one of these, you can email me, and my email address is on every one of my videos on the description, under the description, under the video, and I could share with you a little drawing or something, or explain it a little better. But basically, we had to build that little network to get it to work. Now everything works perfectly. And now another thing you want to know about these, they really, since they're car stereos, they're really better suited to 4 ohm loads rather than 8 ohms now, which is kind of the opposite of a lot of home audio equipment that's really better geared towards 8 ohm. These amps will only put out 8 watts per channel into 4 ohms. So when you put it into an 8 ohm load, you're really cutting the amount of wattage. And these amps can handle 4 ohms, even 2 ohm loads all day long. These are actually what's called 2 ohm stable. So you could actually put a 2 ohm speaker on this. It'll work just fine. It'll actually be louder yet, because it can drive 2 sets of 4 ohm speakers. So let's connect it up, connect some speakers, and let's see what this sounds like. Okay, I now have everything connected, and if we look over here to the right, I'm just using a regular 12 volt power brick, similar to what you would use for a computer or something like that. Just a plain old 12 volt 4 amp power brick. And it just goes to one of those barrel plugs down here. And then I have a couple of just realistic Minimus 7 speakers. They're actually, these are the ones, they actually have the different, the upgraded crossovers and woofers in them. You see them right there and there. And now I have the microphone facing back towards me. I have my external mic, so the sound quality is not going to be that great. I guess I could take the mic off and kind of turn it around a little bit. Maybe I'll do that. Let me turn the mic around, and then we'll give it a test. Okay, microphone is now facing away from me, and I have a little MP3 player over here, and it's on pause right now. Let's turn the stereo on. And the first thing we're going to do is listen to the tuner. So if the switch is flipped to the right towards the antenna jack, we will be listening to the radio. And I guess we should hook an antenna up, shouldn't we? And if the switch is toggled towards the RCA jacks, you'll be listening to the input. So let's start with the tuner.
Never been so it was like me for me.
nice. I mean, it works really well, and the tuner is very sensitive. I wish I could play more music, but of course, you know, we'll get flagged. So now let's toggle it over to the MP3 player. And of course, come on, this is 1970s. We got to play some music from the 70s. What do y'all say, huh? All right, let's see what we got queued up. See if it'll play. Give me a second. It has to boot up. Come on now, I gotta have something from the 70s, some disco. That's what this thing was, the era it was from. So anyhow, you could see it sounds really, really good. It's a clear sounding amplifier. It has a really sensitive tuner. You know, I was gonna go and do a full alignment on it. I may still do that just for fun, but honestly, the stereo indicator on this is working perfectly. The stereo separation is awesome. It's very sensitive considering I'm, you know, where I live and how limited, you know, this tuner, you know, your stations are in this area. You know, wow. So I also cleaned up the cassette a little bit, and if we flip that off, we can pop this in. I think it'll play. Let's see here. Well, maybe not. There we go.
Practice makes perfect if you want to get it right.
I don't even know where I found this tape from. The tape deck is not perfect. You have to kind of help it out a little bit, and you got to kind of help it in a little bit. But it does work, and as you can hear, it doesn't sound bad considering this. I don't even know what this is. I never heard of this. Exile, 1985. So whoever that is. But anyways, there it is. So let's get the covers on it, and we'll take one final look at it. Alright, before we do a couple more tests on this thing, I just want to go over a little bit about the amplifier integrated circuit that's used in these things. If you look at here, the type of chip that's used in here, and we talked about this at the very beginning of the video, it is an AN214. And this is a very common, popular amplifier chip from the 1970s, and there's some things you need to know about it if you don't already know. Number one, it was very common. It was used in many different car stereos, and at the time it was considered to be a very high-end audio chip, even though it is very low powered. If you look at this little printout, they're saying that it's with 13 volts input, it puts out 4.4 watts into 4 ohms, and that's even a little bit deceptive. Now, there aren't any really, they're kind of grainy looking, the data sheets, but NTE does make a replacement chip that's the same chip, and it has the same specs as the grainy Japanese AN214 Matsushita sheet. So let's take a look at a little bit of this, and kind of the, you'll see in the details here really. First of all, if you look at the output power, they're rating the output power at 1 kilohertz, not at 20 to 20 kilohertz, just at 1 kilohertz with 10% distortion into a 4 ohm load. Okay, so every one of those is kind of a strike against this chip, but under those conditions it will put out approximately 4 watts or 4.4 watts typical. So it's not a very powerful chip at all. Now, total harmonic distortion once again, just at 1 kilohertz with only 1 watt power output into 4 ohms is really low. And this was a big thing back then. For an integrated circuit to be able to be this clean, even at low power, that's actually was very good. Now, the thing is with this chip was how they implemented it in the circuit is what really determined how good it performed. And apparently this KP-500 was a very good circuit design the way they used it. Even though this thing's doesn't have very high power output, we're going to find that out in a minute, the sound quality was very, very good. So, for its day. So if you take a look here, here's a typical application of the circuit. And if you take a quick look at the way they do feedback and so forth on there, some of the component values they use, this is the recommended by Matsushita. And if we go over and kind of compare a little bit to the way they do it here, this one is slightly different. So again, let's take a look at the performance of this chip. Now, there are some mods that are floating around out there that people have done, and I printed one out. And basically, this was stuff that you could purchase most of at Radio Shack back in the day. These are MJ2955 transistors, which are big TO3 transistors. And a couple of transformers, a driver transformer and an output transformer. And by doing this, they were able to boost the output power a little bit. But remember, this thing only runs on 12 volts, and there is no boost circuit or converter circuit to step the power up. So the maximum peak, theoretically, that you could have would, if the 100% efficient system, which doesn't exist, would be 12 volts, right? And of course, your RMS value of that would be 0.707 of that 12 volts. So if you take that, you're down to about 8 volts roughly, somewhere in that range, plus or minus. And if you take that 8 volts and you square it, which would be 64, and then divide it by 8, you're down to about 8 watts. So even in a perfect world with a perfect theoretical circuit with 0% loss anywhere, the maximum you could get out of a 12 volt rail would be approximately 8 watts, which you can't do that pretty much the way an amp is designed. So really 4 watts is very reasonable for a 12 volt power supply in the real world. So that being said, let's see how this thing performs. I'm going to use something new here that you guys haven't seen yet. Again, we're just doing some experiments because I'm bored and I can't do a whole lot till I'm cleared to go back to work. So I'm just having some fun at the bench here. By the way, thank you all for a lot of you for the well wishes and so forth. I assure you I'm doing fine. Everything's going well. The surgery was great. I'm really not having much discomfort or anything, so as long as I can stand down here at the bench, I'll play around. So anyways, we have 13.8 volts, which is the recommended voltage for this radio, going into here. And I have a 1 kilohertz signal going into both channels. And I will show you what I'm using here. This is a neat little program. And this little program is called Comtech Synad, and it's made by a company called Comtech. You can buy it online, and I think it's comtekk.com, and it's very inexpensive. And what you can do is, not only will it check total harmonic distortion, but it'll check THD plus noise, it'll check Synad, it'll check all kinds of things using the microphone input of your computer. And what I did is I'm using on my computer, if you can see down here, this little dongle. This is just a USB dongle. It's a USB sound card, and it's made by Creative Labs Sound Blaster, and it's very low noise for what it is. It's a very high quality sound card, which is why I'm using it. And as an option, when you buy the program, you can order this little module. And this little module, if it'll focus on it, or maybe it won't focus on it. Hold on. I can't get it to focus. Alright, there we go. Comtech Engineering. You can see that's the model CT-ISO Max 1. And what this is this is a little isolation unit. It's got a little transformer and a few other components. And this just kind of adds ground loop isolation, and it just gives you a protective barrier between the device under test and your sound card, so you don't ruin your computer. So I'm using that. And again, I can't remember the price, but you can look it up online. So we have our 1 kilohertz waveform on there. And I have it set to measure the RMS output. And if we look over here, let's just see if we can get everything in shot. Right? Zoom in as much as I can. Here we go. So you can see this is reading our total harmonic distortion. And you can see the green range is 10% and below. So let's watch this go up, and let's watch this, and we're going to stop right at 10% distortion. So we're going to go up, 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 and you can see it's starting to clip pretty good, and right about there is 10% distortion. You can see it's reading right around 10% distortion. And if you look at the RMS voltage, it is 3.77 volts. So 3.77 squared divided by 4 ohms, because I'm using a 4 ohm load, is about 3.6 watts. So I'm really not getting the full 4 watts that they're saying that it gets. It's closer to 3.6 watts. And I'm drawing about 1.12 amps at 13.8 volts. And really, that's about all you're going to get out of this little receiver. This is it. Now, if we drop this down to a more reasonable, that's about, you can see right here, it's about just under 3% distortion. And you can see the waveform cleans up really well. But now our power is way down, 2.41 volts. So you can kind of see how, let's see if I can move this a little bit so we can read that. 3.41 volts, I'm sorry. So really you're only looking at about 3 to 3.5 watts per channel into 4 ohms with this receiver. That's all you're going to expect to get out of it. So you might say, why does everybody rave over this little receiver? Well, back in the day, for a self-contained car radio, that was actually doing pretty good. Remember, there are 2 of those little amplifiers in this thing for stereo. So you're getting around 3 watts per channel, roughly. And you're getting it very clean, and you have a full tone control and everything. So, you know, people really like these for what they were. They had very good sound quality for the day. Now, again, compared to what we would do today, and there are modern integrated circuits that will do better than this now, obviously, much better. But, you know, back in the 1970s, this is what you had. I mean, this was it. And if you take a look down here, there's the equivalent circuit inside. And it's not really exactly a quasi-complementary output circuit, but it does use 2 NPNs. It does use kind of a Darlington driver thing, and they're inverting the phase here, so you can kind of see how they're doing all that. A little current source over here, I think, is what that is for biasing the input. Again, I don't know. I didn't really read any theory on this or anything, but that's it. Okay, so to kind of wrap things up, that was just a little bit extra here I wanted to do on this, and I kind of wanted to show you guys this. The other thing is this program, I've had it for a while and I've been playing with it a little bit and I'm kind of getting used to it, but so far I'm really impressed with it. Even like especially for checking synad and things like that on receivers, it seems to be working pretty well. Now, of course, how it will compare to my leader LDM 171, I don't know. The 171 only does distortion and signal to noise. It doesn't do synad, but I know it's pretty accurate. But so far, so good. This thing looks really pretty accurate. It also has a tone generator built into it. You see where it says source right here. If I click on that, it actually uses the output of the sound card to output whatever frequency, whatever fundamental frequency you choose. You can even set the output level, and you can use it as a signal generator as well. Again, you're at the limitation of your hardware, so it depends how good your sound card and everything is. But if you have a good high quality, like a Sound Blaster high bit rate sound card, there's no reason that it shouldn't work really well. So pretty good, and just thought I'd show you all that. But anyhow, that's it for our little car stereo KP-500 project. I thought you'd be interested in seeing it. And I got another project all ready to go on the bench here that I'll be playing with here in the near future. So until then, thank you all, and have a great day.